Hi everyone. Today I want to explain the third part of chapter 1 in part 1, sludge production and characterization. In previous class, we learned about how to estimate the production of waste activated sludge. In order to estimate this, we needed to know WI, WVSS, and BODSOL, which stands for inert portion, and this is same as fixed suspended solid and volatile suspended solid portion, and BODSOL means soluble BOD, and this is a constant, and this equation and this constant was derived from the data from 18 wastewater treatment plants. I think WFSS might be better because it stands for FSS, and in the next term we use WVSS. I just copied this equation from the textbook, so that's why I didn't change it. WI, WSS, WVSS are not soluble. These are solid, but this one is soluble. Soluble means that uh, it's water soluble, so it it cannot be precipitated, and this portion and this portion is a suspended solid. So soluble portion, even if we add some coagulants, the soluble portion cannot precipitate it, but suspended solid portion can be precipitated by using physical chemical reaction. But in wastewater treatment plant, if there is further treatment of physical and chemical reaction, this suspended solid cannot be precipitated. There is, I told you that there is another method to estimate a waste activated sludge production, and this equation was derived by using modeling, and the model for estimating waste activated sludge production based on the yield concept, and this equation is from this article. Q is the flow rate, Y is true yield, BODO is the influent soluble BOD, BODE is the effluent soluble BOD, BD is the endogenous decay coefficient, usually 0.6, and theta is sludge retention time over solid retention time. FSSIO is the influent to FSS. FSSNO is the influent to non-biodegradable VSS. And I will explain this equation in the following class, how this equation is was derived. Anyway, there is some uh, strange things, but I didn't change it because this equation is from the textbook. Anyway, I will explain about this equation in the next class, how to derive this equation, and you need to know how to derive this equation in the exam because usually I ask it in your exam. Sludge yield. This figure shows observed yield versus sludge age, and x-axis is sludge age over solid retention time, sludge retention time. We use both terms, and y-axis is sludge yield. So kilogram VSS for kilogram BOD removed. And the longer sludge age will enhance the more complete destruction of volatile matter and will produce less sludge. So as SLT or sludge age in the bioreactor is longer, sludge yield decrease because longer sludge age will enhance the more complete destruction of volatile matter. Extended aeration system with sludge ages over 20 days produce very little excess sludge because it has very long sludge ages. Attached growth process such as trickling filters and rotating biological contactor has very low sludge yield, 0.1 kilogram VSS per kilogram BOD. But suspended growth system has much larger sludge yield. For example, activated sludge system is sludge yield is 0.5 kilogram VSS per kilogram BOD. So this system has 5 times higher sludge yield than that of attached growth process. In attached growth process, the cells are attached in the media, so that's why it has a very long sludge age because it attached to the system for a long time. But in suspended growth system, the biomass are not attached to anywhere and it is floating on the water. So that's why its sludge age is very short and it has higher sludge yield. So this is usually aerobic system. So how about the cell yield in anaerobic treatment system? You can thinking about it in your homework, and I will give you homework about it. So what is the trickling filter? This is a trickling filter, and this is a rotating biological contactor. So these system using media and biofilm attached to the media. So it that's why in the media, like for example, there is a lot of rocks and stone and biofilm attached on the rock or stone, and in here the disc is rotating and biofilm is attached on the rotating disc. And as it rotating, the biofilm experience the waste, and as it rotating, emit oxygen in the air, and it goes back to the wastewater again. As it rotating, the wastewater can be treated, and in here influent goes through from the bottom, and it goes to the top, and wastewater distributed from the top, and the wastewater passes through the media, and as wastewater passes through the medium, and it can be treated, and effluent goes back to the bottom, and it comes out from the effluent pipe. So there is a four homework. First one, explain bacterial cell yield in wastewater treatment and anaerobic digester. Explain why yields of aerobic bacteria and anaerobic bacteria are different. And second homework is explain how sludge or biosolids are treated in your country. Right, I think there are many Korean students too, but and your country means that Korea for Korean student too, and there is a Spanish student too, and I'm curious about the your law, how to treat sludge and biosolid in your country. So when you needed to submit to your homework, write them in Korean or English. And for Korean student too, I encourage you to use Korean letter rather than English, and submit to your homework to my email. This is my email address. Use Microsoft Word. Page size is A4. Font size is 10 or 11. Line spacing is 1.5. And you can collaborate, but do not copy others' work. So, uh, thank you for listening. And today's class is very short, but you, I think you needed to read your textbook and enjoy your homework, and see you next week. Bye.